This isn't a smart glove, it's something better. Whether you want to control a robotic hand, some LED lights, or anything else you got dreamed up in your mad science lab, this device has you covered.
A few years ago, I started working on an open source prosthetic sensor called OpenMuscle. After I had gone through many iterations of my bracelet prototype, I needed a way to label finger movement data so I could correlate it with signals from my custom bracelet sensors. Visual recognition wasn't an option. I needed high signal to noise and low error rates. I needed precision. First, I tried another open source product, the High Wonder Hand Somata sensor. It used mechanical linkages and potentiometers to track movement, but it was clunky, didn't fit my hand well, and just wasn't accurate enough. Then I tried to make my own mechanical labeler from scratch. Spoiler, that turned into an engineering nightmare. This device, which was supposed to be just a temporary tool, started taking almost as much effort as the original OpenMuscle bracelet. But then, I remembered using a finger exerciser for guitar practice years ago, and thought, what if I could hack this and build my own controller around it? I already knew how to work with Hall sensors and magnets from making the bracelet sensors, so I grabbed the Diodario hand exerciser and started prototyping. My first build used a mini ESP-32S2, some Hall sensors, and a standalone battery charger. I laid out all of the footprints onto a custom PCB within KiCad and sent it off for production. And, as many makers know, the first version came back with mistakes. And the second. And, well, let's just say I have a drawer full of learning experiences. Eventually, I had a working version, the LASK 4. It didn't just label movement data, it could control other devices too. My robotic hand, an LED dodecahedron my friend and I made. Okay, he did most of the work. Funny enough, my maker friends were more interested in the labeling device than the bracelet I had poured months into. With all of the interest and momentum, I decided to take it further. I upgraded the hardware, an ESP-32S3, ESP-NOW protocol, the ability to add Bluetooth, 4 pistons, a joystick, 4 SMD buttons, an OLED screen. I swapped the springs out for lower resistance to make it easier to control other devices, made modular header pins for add-ons, and I revamped the MicroPython code to make it easier to customize the menus. The result? A gloveless smart glove. Open source, open hardware. Simple to build, fun to use, and surprisingly powerful. This is just one little detour on my journey to build better open source prosthetic sensors, but it's been a blast. If you're into DIY tech, human-machine interfaces, or just want to help make a positive difference, check out openmuscle.org. I'm working on the next generation of the bracelet to pair with the LASK 5, and I'll post more videos soon.
If you like this video, please hit the like and subscribe button. That really helps me out. If you're interested in making your own device, the custom PCB files and schematics code, all is found in the GitHub repository. Links found in the description of this video. OpenMuscle is a passion of mine that's been going on for quite some time. I've been making updates as frequently as I can, and I just want to thank you for taking the time to watch this video. Please share it with your friends. Until next time, let's see if we can make a positive difference in this world.